Hello everyone, and my name is Danijela and welcome to tonight's webinar on matrices. Let's get started, shall we? Straight into it. So hopefully you're now seeing my CAS screen. You might notice it looks a little bit different to the way that you're used to seeing your calculator screen. And that's because I'm using what's called a notes page. Now, in a notes page, the reason I've chosen to use a notes page for tonight's webinar is because a notes page allows me to do this wonderful thing, which is cutting and pasting images. So you might recognize this image as well. It's taken straight out of the PDF you have access to, and you should hopefully download it before the webinar started, with all the problems that we're going to do tonight, and also some additional ones for you to practice. So in a notes page, it allows me to cut and paste images really easily into my document. The other reason I've chosen to use a notes page tonight is because you can write text as well as maths. So it really helps me organize my pages a little bit better. And it helps me to link maths boxes. So that means that if I've realized I've made a mistake somewhere in my working, I can go ahead and just change one bit of one line, and it will update every single other line, and you'll see what I mean as we go. Now, not to say that any of these problems cannot be done in a basic calculator page as well. So you can very much still do these in a calculator page. If you are keen to find out more about how to use notes pages, there is an upcoming webinar on the 16th of September with my colleague Craig Brown. I highly recommend registering for that one too. Note pages can be extremely beneficial, especially in exam preparation, and save you a lot of time in an exam if you pre-set up some notes pages leading up to your exam. Okay, so let's get started on the problem one. As you can see, I've got a table that shows some data from a store. It has prices of certain items, and it has the number of items sold in a week. Now have a read of part A. It says, construct a matrix product that, when sold, displays the total number of items sold and the total revenue earned from the sales. Now, I'm curious as to how you would go ahead and set up this particular matrix product. I'm going to scroll down to here's one I prepared earlier solution. It's right here. So I might actually backspace so that you can still see the problem and also see that solution. Now, if you know how to use this software program running on WebEx quite well, you might know that you can raise your hand. So if you know where the raise your hand symbol is, it should be at the bottom right-hand side of the participants panel. If you can raise your hand, if this is how you would set up your matrix product, please do so I can get some sort of indication of who would do it this way. Okay, I think a couple of hands go up already. That's great. Now I chose this problem on purpose because it's a wonderful typical exam style question, first of all. Secondly, it trips up a lot of students, and statistically, not many students set up the product in the first place very well because of a simple problem that they don't read the question very well. Now, the question says that we have to set up a matrix product that calculates not only the total revenue from the sales, but also the number of items sold. Now, this obviously we can see that this product here has given us one result, and it's basically multiplying the quantities of the products by the amount that they're worth and adding all that up. So we've got 3,423. That's giving us the total revenue, but we don't have the total number of items sold. So this is one that usually trips up students. So instead, what we should have done, if I scroll down a little bit, is produce a matrix product that looks like this. And I'm hoping that all those other people that didn't raise their hands would have answered this way. So we've got here a row matrix with the quantities of the product sold. And we've got another matrix, which is a 4x2 matrix that in the first column has all ones, and in the second column has the prices of the products. The purpose of the ones is that they will multiply with the quantities and then add up, so that we know that here, number 74 means the total number of items sold that week, and 3,423. So this part is the revenue. And if you go back to the question in part B, we have to evaluate our matrix product and interpret the result. So when it says to interpret the result, it's really important that you don't leave your answer just as a matrix like that, that you actually explain what those elements inside the matrix mean. Okay. Now, as you can see, I've done this in a notes page, but I can also show you how to do this same thing in a calculator page, and I've done it here. So for those of you who aren't very familiar with using matrices at all on the CAS, I'm going to show you where to find the templates. On the left-hand side, I've got my buttons here, and this button here, the one highlighted in red, is the symbols template, and if you click on it, you'll find some matrices symbol templates. So the first one here, highlighted in blue, is a 2x2 matrix. This is a 1x2, a 2x1, and this symbol here is very useful. Although it looks like a 3x3 matrix, it actually, if I click on it, it allows me to select how many rows and how many columns I want. So if I want my 4, and I'm going to tab across the bottom 1x2, I just do that, I press OK, and I've got my template for that matrix. Okay. Now, the way that I add a new note page or a new calculator page is you can go to Control and Doc, which adds a page. And you can choose what type of page you want to add. For the purpose of this session tonight, we've used calculator pages, which are your standard pages you're probably all very familiar with, and the notes page. So you can add a notes page here, and it adds another page in that same problem. Note that the problem is all problem 1, and the different pages are denoted by the number after the decimal point. So 1.1 is page 1 within problem 1, page 2 within problem 1, page 3 within problem 1. Okay, we're going to move on to problem 2 now, which I've prepared earlier as well. So I've copied and pasted the image of problem 2 here, and you can see that it's dealing with simultaneous equations. So consider the following pair of simultaneous equations, and it's giving you 2 equations that are not in maybe the typical way that you might be used to seeing simultaneous equations. And it says to set up a matrix equation to show how you would begin to solve for x and y. Firstly, before you can set up your matrix equation, you have to rearrange your simultaneous equations to be in a format which we kind of are used to, the traditional format that helps us set up our matrix equations. So I've gone ahead and rearranged these equations like so, and I've typed this in a notes page. It's just text. So this is not maths. So if nothing of this is active, there's no equation that's been evaluated here. It's just simple text as far as the CAS is concerned. So I've got 5x minus 2y equals 16, and I've got 7x plus 6y equals negative 4. Notice now the x's are first in both equations, the y's are second, and the constants are on the right-hand side of the equation. Okay. This then allows us to use this information to nicely set up a matrix equation. I've done this I pre-prepared this as well earlier, but I'm going to show you how to do it because we haven't yet used a notes page with mathematics. So in a notes page, to be able to type in maths that can be evaluated, we need a maths box. So what I'm going to do is press Control-M, which is a shortcut way to insert a math box or maths box into the notes page. You can see it's outlined by the red dots. This means I can put in now equations and anything I want to be able to solve. 1 plus 2 equals, and it will spit out a 3. And with the beauty of a notes page is then I can go and edit anything I've done, and it will automatically update my the equation. So same as in the calculator page, I can access my matrix templates from the symbols template button here, and I've got now a 2 by 2 matrix. So I'm going to use this predetermined template for a 2 by 2 matrix, and then I can go ahead and fill it in. So I've got my 5, the -2, 7, and 6. I'm going to go to the right of the matrix and press multiply, and then I need a 2 by 1 matrix. I'm going to show you one other way to put in a matrix. So I've showed you how to do it through using the symbols template button here, which is next to the catalog button. But there's another little nifty way. And if you go Control and then square brackets, what that will do is just open up what you might call a 1 by 1 matrix. To add another row to that matrix, press on this bottom right return button, and that adds another row. And that's another very quick and easy way to add in another matrix. If you want to add in another column, you can press Shift, return, and that will do that. Okay, but I don't want the other column, I just want that. And then I can put in my X and Y. And then equals, and then I'm going to put in my 16. Oops, I'm going to put in another row there, and -4. Evaluate. Now, all I've done here is written these two equations in a matrix form. And the way I know that I've done that correctly is it spits out basically what I know my equations should be. So it tells me 5x minus 2y equals 16. Yep, I've done that correctly. 7x plus 6y equals -4. Yes, I've done that correctly. It's a good way of checking that you've rewritten your equations in a correct matrix form. Okay, so now it's actually up to us to solve this equation. Now there are two ways I want to show you how to solve this, and I'm going to scroll down to here. The first way is using the solve function, and this is also just text in the notes page. Now the solve function, we're going to first have to add in a maths box. The solve function is one that most of you should be hopefully familiar with. You can either type in solve or menu. Sorry, 1 second. Back. Calculations, algebra, and solve. So a slightly different place from the normal calculator screen. So we've got our solve function, and then we're going to type in everything from the top. So to save some time, I'm just going to copy and paste because I can do that. I'm using the software on my computer. Now, I highly recommend using the software on your computer if you possibly can, because it saves a lot of time. But I know that you might want to get that practice in for exams using your handheld device, which is also fine. So I've got my solve, and I'm going to solve for x and y. So I type in a comma x, comma y, press enter, and it tells me that x equals 2 and y equals -3. And I've solved my simultaneous equation. Another way that you should be familiar with, especially if, obviously, if you're studying the Matrices module, is using the inverse of a matrix. So this is some theory that we hopefully should be familiar with when doing the matrix module, is that if you've got matrix a matrix called A, for example, multiplying by your X and Y matrix equals B. If I want to find the solution for the X and Y matrix, I have to move my matrix A to the other side, so to speak. So if I want to take the inverse function of A, it's the matrix inverse of matrix A. So if I want to find the solution for X and Y, I have to take the inverse of matrix A and multiply it by matrix B. So just to remind you, matrix A, what I'm talking about is this matrix here, and matrix B is the one with the constants on the right-hand side. So to solve for X and Y, I have to take this one, multiply it to the other side, and I have to take the inverse of it first. Okay, so let's do it with that method. I need a math box again, Control M. And again, all of this can be done on your calculator screen. So I need to now type in my equation A. So I'm just going to pull up a template. Here we go. And I've got my equation here. So it's 5, -2, and 7, 6. And that has to be raised to the power of -1. So I'm going to use this hat symbol here to raise it to the power of -1, which makes it an inverse of itself. And then I'm going to multiply it by matrix. So I'm going to put it in this way, this one. Control, open square brackets, and I'm going to insert another row by doing the little return button. I'm going to multiply it by B, which is 16 and -4. Pressing enter gives me a solution in the form of a 2-by-1 matrix. You have to remember that this number 2 here represents the value of X, and the number -3 represents the value of Y. In this case, you cannot just simply answer like this as a matrix. You have to actually remember to state that X equals 2 and Y equals -3 in order to get the full marks for this question. Okay, so that's problem 2 done. We're now going to move on to problem 3, which is about transition matrices. So we're going to move to problem 3, which is on another notes page here. And we can see here, we've got a diagram, a transition diagram, that shows us transitions of people with their preferences for art, music, or sport. So the question says, in the year 2000, a group of 720 adults were asked to choose their most preferred leisure activity. The choices were from art, music, or sport. And we have the values or numbers of people who chose each of those fields. Okay, so the first thing we have to do is to form our transition matrix and our initial state matrix. And now I'm going to show you another very handy feature of a notes page, which is the ability to assign a parameter or a letter to equal your transition matrix, which you can also do in a calculator page, but I'll explain why it's more useful in a notes page in a minute. So I'm going to add a maths box, and I'm going to type in T, and I'm going to put in this symbol here. Sorry, one second. Control. It's a colon equals symbol, and it means to assign. And just you may have noticed, I initially put in capital T, or I can put in a small letter T. It doesn't really matter to a CAS, they're both the same thing. So I'm going to then develop my 3-by-3 transition matrix. Now I know it's going to be a 3-by-3 because there are three different types of states with activities, art, sport, or music. So I'm going to have to use a 3-by-3 matrix. I'll go into here and select this. And so 3-by-3 is the kind of default setting, so I'll press OK. And from then on, I can start to do my transition matrix. Now, just remember the transition matrices, kind of along the top row, you can consider that as the from. So let me just start filling in. I'll explain. 0.2, 0.1, 0.2, and 0.3. So what this 0.2 represents is the transition from A, or art, to art, because they're it's kind of the first row of the first column. So from art to art. This element here represents from art, because the first column is the from, to sport. Now, it's very important that you keep the order very consistent with transition matrices. So I'm going to use art, then sport, then music. Art, sport, music. So art, sport, music. And this one will then be, this middle element will be from sport to sport. So if we look at the diagram, from sport to sport is 0.7. This element here will be from music to sport. From music, because music is the third column, to sport, sport being the second row. From music to sport, there's actually no line joining music to sport, so I'm going to put a 0 in here. Okay. In this element, I'm going from art to to sport, music, from art to music. So art to music is 0.5. So it's, like I said, it's very important to keep it very clear what order you're doing these things in. So the last one is from music to music itself, which we can see as a loop is 0.8. So take extra care to really set up your transition matrix properly. And when you've done it, you can press enter, and it shows you it in green. It's then assigned the variable t as your transition matrix. Now that's very useful, and you'll see why in a minute. We also need our initial state matrix. So the initial state matrix is usually called S0. S0 being state at 0. So I'm going to set up that with a maths box, S0, and I'm going to use the assign button, which is the colon equals on control and then the symbol template, and then I'm going to set up my initial state matrix. It's going to need 3 initial states. So from the question, we can see that initially 380 students chose art, 250 sport, and 90 chose music. And we press enter, and that's now initialized or set as our initial state matrix assigned to it. Okay, so then what we want to do, typically in exams you might have a question like, the next time they choose, or the next year they choose, how many will choose what? And in that case, you simply multiply the transition matrix with your initial state. This particular question says, how many adults will choose music in 2003? Initially, our initial year was the year 2000. In 2003 means 3 years have passed since the year 2000. That means that 3 transitions have occurred since the year 2000. So we need to make sure that the transition matrix is applied 3 times to our initial state matrix. And the way we do that is, let's put in a maths box, state 3, after the 3rd year, equals the transition matrix. And we don't have to retype it now, everyone, because we've already assigned the variable t to represent it. So we can just write t to the power, so we do a hat symbol, 3, multiplied by the initial state matrix. Enter. Okay, something's happened here. 1 second until I figure it out. Oh, I know what I've done. I've used, instead of using the assign, I used an equal. It just asks, is that equal to that? I should have used the assign symbol there. All right, so we're assigning the state or the matrix, so the result in the third year is the transition matrix to the power of 3 multiplied by the initial state matrix. And so we've got here the results. So we can see that, how do we interpret this matrix? 120.2 means that approximately 120 people will choose art in the year 2003. Approximately 201 people will choose sport, and approximately 399, rounding up, will choose music in 2003. Once again, it's important to interpret the results from your matrix. Very often students just leave the matrix answer and don't explain it in words, which doesn't show full understanding to whoever is assessing your exam. So make sure that this is always interpreted. Okay, let's go on to the next part of this problem, which is problem 4 in your worksheets. But it's still related to problem 3, so I've kept it as 3.2 on the notes page here. The adults from problem 3 were tracked over many years, even decades. Set up an equation to show how you would find how many of them chose each activity in the nth year after 2000. Now the nth year, so it can be the 5th year, so 2005, it can be 2020, it can be 2030. We don't know which year n is. So Sn is the result or the number of people in the year n. All we have to do is get our transition matrix, raise it to the power of whatever year has passed, however many years have passed, and multiply that with the initial state matrix. So just like we did in the earlier question, we knew that 3 years had passed, so we raised our transition matrix to the power of 3 and multiplied it to the initial state matrix. So here we're doing the same. We're just setting up a general equation that can be used for any value of n. Now, part B is one that's asked very often with these kind of questions. It talks about the long term. Now, in the long term, these numbers reach a sort of steady state where they don't change that much after a while. So what we can do here is to figure out the steady state numbers. We can either do 2 things. We can open a math box here and do our transition matrix T. Notice that it's bold, which means it recognizes it as a variable. And let's choose a really ridiculously large number of years have passed. Okay, so let's say 50 years have passed since 2000. We can raise T to the power of 50 and multiply that by the initial state, S0. And let's see what the answer is. Okay, we've got an answer. We've got about 131 people in art, 131 in sport, and 458 in music. Let's see what happens if I do the same thing with, I don't know, let's say 60 years. Okay, let's go T to the power of 60 times S0. Oh, the solution, the answers look very similar, don't they? So we can say that they've reached a steady state. And you can simply do this and just say, to justify your response, say, I've from the 50th year to the 60th year, there hasn't been much change. Therefore, I can safely say that these numbers are my long-term numbers. Okay. Now, there is another really nifty thing I want to show you to use in the CAS, which is a slider. So I'm going to insert now a slider. Now, just follow along and you'll see the reason for it in a minute. I'm going to go to Menu, Insert, and number 5 is Slider. Now, I'm going to call this slider Variable N. And I'm going to put the minimum value of the slider as 0 and the maximum, let's go all the way to, I don't know, 50 years. Because we don't really need to go for longer than 50 years tracking these adults and their leisure choices. We can go in a step size of 1 and let's press OK. Oops. Oh. There's my slider there. So I can simply slide it along and change the value for n. And then in my new, I'm going to insert a maths box here. I'm going to start my equation, which is my transpose matrix, which it already knows because I entered it in page 3.1. And because we're in the same problem within the notes page, it remembers it, which is wonderful. This is not something you can do in a calculator page. Another reason to use a notes page. T to the power of n multiplied by S naught, which is, it's our initial state matrix. I'm going to go enter here. So currently, because my n is set to 0, these are just my initial values. You can see that if I change the slider, move the slider along, these values change. Let's go to number 3, because 3 is interesting, because I think we did this question earlier, didn't we? We did it on 3.1. And we can see that those values are the same. In 3 years, 120, 201, 399. And we can keep sliding that slider along until we see stability of values. So some sort of steady state has been reached. Okay, so I can see that's already happening as early as somewhere here, as early as maybe, I think, around 15 years later on. And that's how you justify it. Remember, it's the justification that they're also looking for in an exam. So you can't just say that my steady state, my long-term values are 131, 131, and 458. You have to explain how you know that they're your steady state solutions. And you can say that from the 15th year to the 16th year, there hasn't been much change. Or like I did earlier, from the 50th year to the 60th year, there hasn't been much change. And that shows that you've understood the meaning of the long-term or steady state. Okay, so that's the end of the content I wanted to cover tonight. There are a few other practice questions that I've prepared for you on the PDF, which you can download. And they've got full work solutions with them. Like I said, this webinar, I've done everything on notes pages, and if you're not familiar with them, it would be really handy for you to attend the notes page webinar on the 16th of September that's coming up. Really highly recommend that one. And I hope you've gotten a lot out of tonight. Thank you very much for listening.